Hello students, welcome to this practice video where we're going to be looking at connecting the derivative of a table and connecting that with the original function. No more longer intros, let's get right into it. So in this problem, I want you guys to first notice is that what we have here is we're given h prime of x. Notice again, this is a table for the derivative h prime of x. And so when we're getting into our questions, you want to keep in mind, we're given the derivative. We're not given the function where we have to find derivatives. We're given the derivative and we need to make connections elsewhere. So here we want to see on what intervals is the function h of x increasing and decreasing. So h of x is increasing when h prime of x is greater than 0. Again, these things need to be embedded in your bones, in your soul. And that's going to be happening, when are these values going to be greater than 0? So I'm looking here and I'm looking, okay, so all of those values, I've got that 0 at -2 and I got a 0 at 7. And everything else is negative except for -8, -5, and -2. All those h prime values are going to be positive. So that's when, those are the values that I want to grab. And so that's going to happen in between -infinity all the way up to that 0, which is at -2. And so h of x is decreasing when h prime of x is less than 0. So again, you want to have that idea embedded within you. It's like, decreasing when h prime, when the derivative is negative, decreasing negative, increasing positive. And when are we looking at negative values? Well, that's pretty much happening everywhere else in the table, but we want to not include those zeros. So I'm going to write down from -2 to 7, union 7 to infinity. Those are going to be the values where the derivative is going to be negative. So now you want to think, okay, at what x values does the graph of h of x have a relative maximum? Well, a relative maximum is when your function is going from increasing to decreasing, something like that. And the way we're going to be getting that happening when we're given the derivative, so increasing, positive, decreasing, negative. So when our derivative is changing from positive to negative, so it's changing from positive, hit 0, goes down to negative. So where is that happening in my graph? So in my graph, I'm going from positive to negative when x equals -2. And that's going to be my reasoning. So we'll say h of x has a relative maximum at x equals -2. because h prime of x changes from positive to negative. So now we want to look, okay, at what x values does the graph of h of x have a relative minimum? And again, you're looking at this table up here above, and you're saying, okay, h prime of x is going to have, or sorry, h of x is going to have a minimum when you're going from a decreasing part to an increasing part. So decreasing negative, increasing positive. So decreasing negative, increasing positive. So where are we changing from negative to positive? And I'm looking at this table, and we don't have any negative to positive changes. So here it's going from negative to another negative right there. So we don't have any definitive proof that we're having any change from negative to positive. So we can't say that we have a relative minimum in this case. So now if h of 3 equals 2, we want to write the equation, the tangent line here, and the equation, the normal line. Okay, so h of 3 equals 2. So what's my point of tangency? That's going to be 3, 2. And I want the derivative, so I want the slope of the tangent line. Well, we're given the derivative in the table, and where am I going to look? Well, I'm going to get the derivative when x equals 3. So I'm going to go back up to my table here, and at x equal to 3, my derivative comes out to be -3. So my slope of the tangent line is going to be -3. And so if I write out my equation, that's going to be y minus 2 equals -3 times x minus 3. Well, now I want to do the normal line. And so the normal line, I want to get the slope of the normal line, and that's going to be the negative reciprocal, so that's going to be positive 1/3. And now I'm going to use that same point. So y minus 2 equals positive 1/3 times x minus 3. So that's going to be the equation of the tangent line and the equation of the normal line. Now, similar to that first video, we want to find the tangent line approximation of h of 3.1. So we're going to use our tangent line and we're going to substitute in 3.1. So y minus 2 equals negative 3 times 3.1 minus 3. Okay, so 3.1 minus 3, I'm going to get 0.1, so negative 3 times that, and then y minus 2 still. So negative 3 times 0.1, that's going to get me negative 0.3, so y minus 2 equals negative 0.3, and I'm going to add 2 to that. So 2, that's going to get me 1.7, so y equals 1.7, and we'll say that h of 3.1, and since this is an approximation, is approximately 1.7, and that's our tangent line approximation. If you're so confused on that, go back to that first video where I explain more in depth why our tangent line is a good approximation for a close point. And lastly, we want to find the value of each of the following limits. So, well, the limit of h of x as x approaches negative infinity, we want to say, okay, what's happening on the left side of our graph? So since my function is increasing on the left side of the graph because everything was positive, so everything is increasing, that means as I'm going to the left, since everything's increasing, since I'm going to the left, h of x equals negative infinity. And then on the right side, everything was decreasing. So if everything on the right side of the graph is decreasing, so as I read that to the right side, my value for the limit comes out to be negative infinity as well. So negative infinity and negative infinity. I think these last two parts might be a little bit confusing, so if you do need any help with that, make sure you guys do reach out to me so you can schedule an appointment so that you can figure this out. You guys know I'm always here to help you. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.